So in today's session, I'm going to do some worked examples from actually 10, 10 numbers from, past paper questions on just indices and logarithms. While I am doing these numbers, I don't expect you to just watch me like you're watching a movie. I encourage you to get a pen, a piece of paper, or a book, and your calculator. As the number begins, if you feel you can do the number, pause the video, try it out. If you get an answer after trying it out, then play the video to see if the answer that I am getting agrees with what you're getting. I believe by doing so, you will be consuming this content in a much more beneficial way than just watching me passively, doing these things. So let's get started without any much wastage of time. My name is Arnold Kisembo Rwanga Kuramia, and this is Kisembo Academy. We have a number here. Simplify log of 15 minus 2 log of 10 plus log of 60. So now one thing that you need to know is, number one, you need to know the laws of logarithms. I assume you learned those in your class. They have to be at your fingertips because it is by these very laws that we use to simplify these numbers that we are doing right now. And then two, so I'm going to, that is the background I have as I do these numbers, that the concepts have been introduced to you in class, and here we're just doing revision. However, if you feel there are certain aspects that I need to delve into more deeply, simply let me know in the comment section below, and I'll be able to get back. So simplify logarithm of 15 minus that and that. So first of all, this logarithm here does not have a coefficient. Here it has 2, and here it has nothing. So let's first make everything, have coefficient of 1, so meaning that log 15 minus 2 log of 10 plus logarithm of 60 is equal to, we shall say it is log of 15 minus, now from the laws of logarithms, we can shift this 2 and bring it up there. Okay, so it means this is going to be minus the log of 10 to the power 2 plus log of 60. Now, numbers that are just having log 10, log 6, log whatever, without a base, we assume that they are base 10. So in other words, all these logarithms that we are dealing with are log base 10, even if the 10 is not put there. But that is what it means. So it means that since they are all of the same base, what we do is that we maintain that base. We shall say log, base 10. Let me just put the 10 for the sake, but even if you do not put it there, it's okay. Log base 10, and then we shall handle this. So we have 15 minus 10 plus 60. So according to the laws of logarithms, when you're subtracting two numbers of the same base, we divide the numbers. So it means that here it's going to become, here we have 15 and 10 to the power 2. So what we are going to, since there is minus there, so this is going to be 15, divide that by 10 squared. And since this is plus, so this is going to become multiply that by 60. So of course this is going to become log of all this base to the base 10, so that's going to become 15 times 60 divided by 100. The answer we get here is 9. So of course when we simplify all this, we are going to end up with log of 9. And we can't go further than that, so that's our answer. So the answer is log 9 base 10. Moving on to the next one. Of course, if you want to see whether you're really you're on track, or whether what you're doing is correct, just type this in your calculator. See what answer you get. If it's equivalent to what you get when you type this in the calculator, then you are on track. So for x in this, of course, solving for x from that's going to be 32 to the power 3 over 5. Divide that by x to the power a half is equal to 2. We are going to make x the subject of the formula since we are trying to solve for the value of x, right? So this is the same as saying 32 to the power 3 over 5 over x to the power half is going to be equal to 2. So we are trying to make x the subject of the formula multiplied by x to the power half on both sides, so that this value of x and that cancel. So what we are going to remain with here is 32 to the power 3 over 5 is going to give us 2x to the power a half, like that. So now, if you look at this further, 32 to the power 3 over 5 is the same as saying 32 to the power 1 over 5, like that. And this is to the power 3. That is what it means. We are splitting this 3/5. Let me do it. This 3/5 has been split. 3 over 5 is the same as saying 1 over 5 times 3. That is how I've split it here, right there. So it is 3 to the power a fifth to the power 3. That's how it has been split. This is equal to 2x to the power a half. So now, 32 to the power a fifth means I'm going to find the fifth root of 32. So to find the fifth root of 32, let me do some side work here. 32, if I divide that by 2, I'm going to end up with 1, 16. By 2, I'll end up with 8. By 2, I'll end up with 4. Divide that by 2, I'll end up with 2. Now, since we are finding a fifth root, I'm going to group these numbers in groups of 5. 1, 2, 3, 4, 5. When I group these numbers in groups of 5, I'll simply choose one of them, one number from the group. And so it means the fifth root of 32 is actually 2. So this means it's going to become 2 to the power 3 is going to be equal to 2x to the power a half. That is what it is reduced to. So remember, this is going to become 2 times 2 times 2 is equal to 2x to the power a half. Let me divide both sides by 2. Remember, we're interested in finding x to the power half. So 2 and 2 go by 2 once, by 2 once. You remain with 2 times 2, which is 4, is equal to x to the power a half. Now remember, x to the power a half is the same as saying the square root of x. So square root of x is equal to 4. So to remove this square root sign, I'm going to square both sides, right? So square that and square that so that this square root sign goes with that. You remain with x being equal to 4 squared, which is 16. So it means my value of x is 16. And that's the answer. Moving on to the next, without using tables or calculator, find the value of those numbers that are being given to us, as you can see. So again here, without using a table or calculator, find the value of 2 log 50 and that and that. So let's do that. So of course 2 times the logarithm log of 50 to base 10 plus log of 80 base 10 minus log of 2 base 10. That is going to be equal to, now these all have the same base 10 base 10. Now remember, with base 10, even if I do not put that base 10 down, it still remains base 10. So we shall first make sure that they all have 1. Here there is 1, here there is 1, here there is a 2. I'm going to shift that 2 and bring it up here so that they are all uniform. So it means it's going to become the log to base 10 of 50 squared plus the log to base 10 of 80 minus log of log of 2 to the base 10 here. So it's log of 50 squared to base 10, then log of 80 to the base 10, then log of 2 to the base 10. So that's going to be equal to, so since they all have the same log, the logarithms have the same base, so I'll maintain that logarithm. So it's going to become log to base 10. Let me just put the 10s there. So it's going to be logarithm of, that is 50 squared. Now 50 times that, so that's going to become, that is 50 squared. Multiply that by 80, divide that by 2. We divide by 2 because of this is minus 2, so we divide by 2. So what we shall end up with, this is going to become log, the logarithm of these numbers to the base 10, so means this is going to become, when we punch all that in our calculator, we end up with 100,000. So this is going to become log of, this is 100,000 is 10 to the power 5. So log of 10 to the power 5 to the base 10. So this means we are going to transfer this 5 and bring it right there according to our logarithm laws. So this is going to become 5 log of 10 base 10. And of course, when we have the log of a number and its base being the same, this is equal to 1. So this becomes 5 times 1, and our answer is 5. So that's how we simplify that without using, tables. So part B. Part B requires us to find the prime factors of 150. So what are the prime factors of 150? Let's face them. Let me do that here. This is part B of the question. They want us to find the prime factors of 150. So when I look at prime factors of 150, I'll begin with, divide that by 2. What do you end up with? 75. Divide that by 3. What do you end up with? 25. Divide that by 5. I'll end up with 5. So it means that for the prime factors here, they are 2 times 3. So you can express these ones as 2 times 3 times 5 squared, like that. Those are you've expressed 150 as a product of its factors, like that. So that's part B. Then part B Roman 2, they're asking us, use your result in 1 and 2 to find the log to base 10 of 150. So again, simplifying that number, let me just do it here, part C. I'm doing part C here. So because of space, well, I'll keep squeezing my work. So using your result in 1, find log, they want us to find the log of 150 base 10. So of course, finding that, this is going to be equal to, log of the number. Now this 150 here that you're seeing here, remember we found its prime factors earlier. We found its prime factors there. And we said there were 2 times 3 times 5 squared. So this is the same as log of 2 times 3 times 5 squared. We've converted that into its prime factors, right? So we continue by saying that is going to be equal to, now that is the same as saying log to base log of 2 base 10 plus log of 3 base 10 plus log of 5 squared. This is also to base 10. Remember, Roman 2 is telling us that use your result in 1 to find log 10. So we are using the result here in Roman 1 to find it. So that's how we break it down like that. Because it's multiplication, the logarithms turn out into plus. That is in the laws of logarithms. Those are foundational concepts when the topic was being introduced to you people. So that's going to be equal to, now what's the log of 2 base 10? According to our question here, we have been told that the log of 2 base 10, log of 2 base 10 is given in the question as 0.3010. So that is 0.3010 plus log of 3 base 10 is 0.4771, 0.4771 plus log of 5 squared, that is actually, this is the same as 2 log 5. So of course this is going to continue as that 2 came from up here. This is 5 squared, so that 2 came down there. So that's why it's 2 log 5. So it means that this is going to be equal to, let's first be adding those ones, 0.3010, adding that to 0.4771. This is going to give us 0.7781 plus 2 times log of 5. Now log of 5 up here is given by 0.6990. So this is times 0.6990. And so our answer here will be, so the answer for part C is 2.1761. So following the logarithm laws, the laws of logarithms, so log of p over q is the same as saying log of p minus log of q squared. This is the same as saying log of p minus 2 log of q, or I mean log of q. This 2 here has been shifted from up there and it has been put there. Following the principles of logarithms that I assume you already know. So this is going to become log of p, of course according to the question, log of p is 2.476. So this is going to become 2.476 minus, that is 2 times log of q, which is here, it's showing bar 1. So it is bar 1.811. So yeah, one of our logarithms there has a negative characteristic. So this is going to become 2.476 minus, to multiply this next number that you're seeing here, it is actually 2 times, now we are having in the brackets, we are having a number, a logarithm that is having a mantissa and the negative characteristic. In other words, we have this as the negative characteristic and this is the mantissa. Now let me do this as side work so that I just come back down here with the final answer. So 2 times, multiplied that by bar 1.811. This is the same as saying 2 times, okay, in brackets we put, that is 1, negative 1, plus 0.811, something like that, okay? So in other words, let me actually just do it in a structural way, like this. This is going to be equal to 1, that is bar 1.811, multiply that by 2. When I multiply that by 2, that's 2 times 1 is 2, 2 times 1 is 2, 2 times 8 is 16. So I'll write 6, I'll carry the 1 here. Then so this is going to become 2 times that negative 1. Remember that negative 1 is independent. So 2 times negative 1 is negative 2. The negative 2 plus the 1 that we carried gives us negative 1. So this becomes bar 1.622. So it means that our answer here is going to become bar 1.622, like that. And then we shall go ahead and subtract the 2. So let me do this like this so that it comes out very well. So it becomes 2.476 minus bar 1.622. Subtracting the 2, 6 minus 2 is 4, 7 minus 2 is 5. Now then here we have 4 minus 6. 4 minus 6 is not possible, so we shall borrow 1 from here. We remain with 1 here, so this becomes 14. 14 minus 6 is going to give us 8. Then here at the negative characteristic part, it's going to become 1 minus negative 1. 1 minus negative 1, this becomes 2. So this is 2.854. So it means our answer here is 2.854. Now, for some of you that might be getting confused about how I'm arriving at that answer, I have a video on the mantissa, how to add, subtract, multiply, and divide logs with negatives. Yes, I have that video. I'm going to leave a link to that video in the video description below. And maybe just for this specific, how I've been dealing with this, let me just play it briefly, just to throw more light for some of you that are looking at this for the first time, but I would really recommend that you go and watch it so that you're able to understand what we're doing here. Here it is. We shall say it is 2.6249. That is minus this 2.413. Oh, it is 2.4135. This 2 is right, not there. So when you have to subtract those, it's going to become 9 minus 5 is going to give us 4. 4 minus 3 is going to give us 1. 2 minus 1 is going to give us 1. Then 6 minus 4 is going to give us 2. Decimal point. Then we shall add this. This negative only affects that number. It does not affect the rest of this part. So it's negative 2 minus 2. That's giving us 4 bar. Negative 2 minus 2 is going to give us negative 4. So how do we multiply them? Multiplying them is going to be, so 2 times 5 is 10. So you write here is 0, you carry 1. 7 times 2 is 14. 14 plus that 1 is going to give us 15. So you write 5, carry 1. 2 divided by 3 is 6. 6 plus 1 is 7. Then 2 times 4 is 8. Then we have 2 times 3 bar. 2 times 3 bar is 6 bar. So when we are multiplying these numbers, when we are multiplying logarithms, because this is a logarithm, we do it in such a way that we are going to multiply this by the characteristic will be multiplied independently from this. So it means that the answer here we are getting is 6 bar 0.8750. If you look at it this way, this is like saying 2 multiply that by negative 3 plus 0.4375. This is how we should look at it. That this negative 3 is independent. 2 times negative 3 gave us negative 6. Then 2 times 0.4374 gave us 0.8750. That is how we should look at it. Let's look at the next example.
Now still, when you're multiplying this, this is the same as saying 4 multiply that by negative 4 plus 0.62401. We are going to multiply the two independently. So this negative only affects this part. This is free of that. It's still positive. So it's 4 times 1 is 4. 4 times 0 is 0. 4 times 4 is 16. So 6 carry 1. 4 times 2 is 8 plus 1 is 9. 4 times 6 is 24. So you write 4, you carry 2. So 4 times negative 4 is going to be negative 16. Negative 16 plus 2 plus positive 2 is going to give us negative 14. So it becomes bar 1 4 point, like that. And that is how we multiply logarithms with negative characteristics. Now we are going to look.
That will do for the snippet. To watch the entire video, the link is in the video description. Let's continue with these worked examples on examination past paper questions. Moving on, evaluate this number. This is an index number, 16 over 81 to the power of that. So that means this is 16 over 81. If this whole thing is to the power negative 3 over 4, it means this is 16 to the power, 81. But what we are going to do is we are going to divide that, You see this is negative 3 over 4 is the same as saying a quarter times negative 3. So we isolate their quarter, and their quarter is what we're going to put up here. So this is going to be equal to, if I may put this another bracket here, so this is going to be equal to a quarter, and then this whole thing is to the power negative 3. Now that this is more like there is a multiplication sign here in between. A quarter times negative 3 gives us negative 3 over 4. But I've just decided to split them into two like that. So after doing that, so this simply means that this is going to be equal to 16 to the power a quarter over 81 to the power a quarter, but this whole thing is still to the power negative 3. So now let's deal with these things individually. What is 16 to the power a quarter? 16 to the power a quarter means we are going to find the fourth root of 16. So doing some side work here, by 2, we end up with 8. By 2, we end up with 4. We divide that by 2, we end up with 2. And since we are finding the fourth root, it means we are going to group these numbers in groups of 4 and just choose one from each group. So here it was one group, and we are only going to choose one number, which is 2. So it means according to this is going to be equal to, the fourth root of 16 is 2. Divide that by, now let's look for the fourth root of 81. So I'm going to do the same thing, the fourth root of 81. I'll come here and say 81 by 3. That is going to be 27 by 3. It's going to give me 9 by 3. It's going to give me 3. And if you look at these figures, since we are finding the fourth root of 81, we group these factors in groups of 4, since we are looking for the fourth root, and it's 1, 2, 3, 4 groups. We only choose 1, 3. So it means that the fourth root of 81 is 3. We solved that one also. So it's going to be 2/3. This is to the power negative 3, like that. So that being done, we can continue by saying that this is going to be equal to, so to remove this negative, it means we simply make this the reciprocal. Remember, any number to the power negative something, let's say if I said 2 to the power negative 1 is the same as 1 over 2, right? Because this is 2 over 1, right? So if I say a number is 3 to the power negative 2, this is 3 over 1, right? If it is, this is the same as saying 1 over 3, and this whole thing is to the power 2. That is if you want to eliminate the negative. you simply do the reciprocal of that. So meaning here 2 over 3, if we want to eliminate that negative to the power negative 3, we simply have to do the reciprocal of whatever is there. So it means this is going to be 3 over 2, and this is going to be to the power 3. This is coming from your laws of indices that were introduced to you in class, but I have a full video on that that explains all those things in detail. So this is going to be equal to, of course, this is the same as 3 to the power 3, divide that by 2 to the power 3, and this is going to become 3 to the power 3 is 3 times 3 times 3, divide that by 2 times 2 times 2, and our answer shall be, this is going to be 27 over 8. And that's the answer. Moving on to the next. Express these logarithms as a single logarithm, okay? So express 2 log of 18 base 3 plus log of 3 to the power negative 1 base 3 minus log of 6 squared base 3 plus 1. We want it as a single log of base 3 and q. So it means that everything has to first be to log 3. Remember, this is 1, and we know that according to the laws of logarithm, the rules, if you have a log to a certain number, let's say m, and the same number has the same base, this is always equal to 1. So it means that that's how we are going to deal with this one right there. So moving on to the next step, we can as well move these 2 up there, since we want everything to be log base 3. So this is going to become log of 18 squared base 3. That is going to become plus log of 3 to the power negative 1. This is base 3 minus log of 6 squared base 3. Then this is going to become plus, since we are dealing with log 3, I'm going to call it log of 3 base 3. That is explaining this. We've converted the 1 into log of 3 base 3. Since everything is now according to log 3, log base 3, it's the same log, so we shall maintain that log. We shall say log, let's write the base right there, then we start manipulating the things in here. So that is 18 squared, so we shall say it's 18 squared. Since we have a plus here, we shall multiply here, times 3 to the power negative 1, that is 3 to the power negative 1 there. And then let's first deal with the addition, plus 3, so let's multiply that by 3, okay? Then minus this, so minus is division, that we shall divide that by 6 squared, like that. And so the rest is just arithmetic. So this will end up, we shall end up having log of this, whatever is we're going to get here as the answer to the base 3, and what we have there is 9. Now our question requires us to find, to convert that number into a single logarithm, as you're seeing here, log of q base 3. And definitely this becomes our final answer. It is log of 9 base 3. So our value of q is 9, and that's the answer. So moving on to the next, if 4 to the power x times 2 to the power y over that is equal to that, express p in terms of x and y. So expressing p in terms of x and y, we're simply going to try and see that p, this side resembles the other side. Anyway, let's get started. This is 4 to the power x times 2 to the power y. Divide that by 2 to the power x plus 2y is going to be equal to 2 to the power p. So let's get started with this. So let's convert everything to 2. This is 4 to the power x. We know that if we factorize 4 by 2, we get 2. So in other words, 4 is the same as 2 squared, right? That is what it means. 4 is the same as saying 2 squared. So this 4, we shall come here and say that 2 to the power, 2 squared. That is like 2 squared, something like that, to the power x times 2 to the power y, divide that by, that's going to be 2 to the power x plus 2y, like that. It's going to give us 2 to the power p. So we continue like that. This is definitely 2 to the power 2x. I am moving quite slowly, but it's okay. 2 to the power 2x times 2 to the power y. Divide that by 2 to the power x plus 2y is going to give us 2 to the power p. So according to the law of indices, when the bases are the same, we shall add the powers. So this is going to become 2, and the powers we shall add is 2x plus y. Divide that by, we come down here and it becomes 2. That is x plus 2y. That is still going to give us 2. Again, from the laws, our laws of indices, when the bases are still the same and you're dividing the two, we subtract the powers. Remember, this is 2 to the power p. So we continue like that. That is going to become, we put the 2, and then we shall say this is 2x plus y minus the bottom power, which is x plus 2y. Is going to give us 2 to the power p, like that. So from there, we are able to see that, of course, these two, the bases are the same, these two and that two are the same. So if these two and that two are the same, it means also the powers, this power should be equal to that power. So it is from that point that we shall just simply go ahead and say that this means that P is equal to 2x plus y minus x plus 2y. Then from there, remember our question says that express P, express P in terms of x and y. So what is remaining is simply just collect like terms and simplify the expression. Otherwise, we've already expressed P in terms of, x and y. We've already done it. We're just going to continue expressing, simplifying it further into, a simpler version. So this is going to become 2x plus y minus x minus 2y, we are opening brackets there, is equal to p. Collect like terms on this side, so this becomes 2x minus x. Then we have plus y minus 2y is equal to p. 2x minus x is x, then y minus 2y is minus y is equal to p. And then from there we can see that p is x minus y. So that's the answer. We have simplified, we have answered the question. Simplify this using indices, so this is going to become 12 to the power 3 over 2. Multiply that by 16 to the power 1 over 8. Divide that by 27 to the power a sixth. Multiply that by 18 to the power a half. So this is the same as saying we are going to try and find the we factorize these figures so that we simplify whatever we are seeing up there. So let's look at 12 here. 12 by 2 is 6 by 3 by 2, we remain with 3. That is 12 for you. So 12 means is the same as 2 to the power 2 times 3. Let's go on to 16. 16 16 by 2 will give us 8, by 2 it will give us 4, by 2 we'll end up with 2. So 16 is the same as 2 to the power 1, 2, 3, 4. Let's get to 27. 27 by 3, it will give us 9, by 3, it will give us 3. So 27 is the same as 3 to the power 3. Let's get to 18. We simplify this. By 18 by 2, we end up with 9. By 3, we end up with 3. So it means that our 18 here is going to be given by 2 times 3 squared. That is what it's equal to. So our original question is going to turn out into this. So where we are putting 12, we are going to instead say this is going to become 2 to the power 2 times 3. This whole thing is to the power 3 over 2. This is where I'm trying to rewrite this. So multiply that by 16. Where there is 16, we put 2 to the power 4. So it's going to be 2 to the power 4. And this is to the power 1 over 8. Like that. Then we shall divide by, where there is 27, we put 3 to the power 3. So this is going to become 3 to the power 3. And this whole thing is to the power 6th. Multiply that by 18. Where there is 18, put this. So it's going to become 2 times 3 squared, and this is to the power a half, like that. I believe by that we have simplified it. Now, since we've broken it down, now let's start dealing with each individual thing. So from here you can see that this is the same as 2 squared to the power 3 over 2. This is multiplied by that, yeah? The power 3 over 2, multiply that by 3 to the power 3 over 2. In a way, I'm kind of opening brackets. Multiply that by, now this is a quarter times an eighth. So this is going to remain as 2 to the power here by 4 once, by 4 twice. So it's 2 to the power a half. Let's get all that divided by, here it's by 3 once, by 3 twice. So this is going to become 3 to the power a half. Multiply that by, that is 2 to the power a half. That is coming from this a half multiplying by that. Then we have this 2, multiply that by 2 once, by 2 once. So this remains 3 to the power 1, like that. So continuing, this 2 and that 2 will cancel. We shall remain with 2 to the power 3. Multiply that by 3 to the power 3 over 2. Multiply that by 2 to the power a half. Divide that by, of course here we have 3 to the power a half and the rest. Let's combine like terms. We have 3 to the power a half. Multiply that by 3 to the power 1. Multiply that by 2 to the power a half, like that. So we continue. So the top part, it's going to become 2 to the power 3. Multiply that by 2 to the power a half. Multiply that by 3 to the power 3 over 2. Divide that by, of course, let me maintain the bottom the way it is, 3 to the power a half times 3 to the power 1 times 2 to the power a half. From this, we are able to see that certain things can cancel out. For example, this 2 to the power half can cancel out with that 2 to the power half. And what do we remain with? We continue remaining on the bottom. On the top, we have 2 to the power 3. Multiply that by 3 to the power 3 over 2. Divide that by, of course, this is 3 on the bottom. The bases are the same. Add the powers, that is a half plus 1. Yep. Then from there, we can see that this is continuing to being 2 to the power 3 times 3 to the power 3 over 2. Divide that by 3 to the power a half plus 1 is 3 over 2, right? Three to the power 3 over 2. You realize that from there, this will cancel with that, and then we shall end up with 2 to the power 3. And 2 to the power 3 is the answer. So after simplifying that, our answer is 2 to the power 3. Now, in doing this lecture, I have left out numbers like this, examination question numbers like this, that require us to use logarithm tables. Even that number requires us to use a logarithm table. I have left them out just to avoid this video from being too long, because I think these numbers are quite long, and because while doing them will require that I'm supposed to use anti-log tables. However, so I have decided that I will do these kinds of numbers in a separate video where I will expound on how we use log tables to evaluate these kinds of numbers. If you are interested in looking at these kinds of numbers, simply let me know in the comment section below. Otherwise, for this session, we have come to the end of it. Thanks for tuning in. My name is Arnold Rangakuramia, and this is Kisembo Academy. Take care.